Hello. Well, hopefully those first three were the basics and you got it going. Today's short lesson and a little bit of practice. It's called theoretical probability. And basically, if you can count the number of successes over the number of trials, that's what theoretical probability is. So let's look at, the octagonal spinner. Yes, world famous. There you could roll that and get a 1, 2, 3, 4, 5, 6, 7, 8. So that is our universal set. Whoa, we're in highlighter mode. That's always good. This is equal to our universal set. Those are all the possible outcomes. Great. Hey, there's a lot of assumptions going on in math book, um, book math, whatever. That everything's equally likely, that those are perfectly spaced apart and all that. So we'll go with that. Life's easier. Obviously, the probability of getting one of those is 1 out of 8. All right. So they have a rule. Look at this. If the sample space has n outcomes and they are all equally likely, then guess what? 1 over n is the probability of each one. Awesome. Makes sense. You could roll a die. There's 6 outcomes. You got a 1/6 chance of rolling a 5 or a 3 or a 2, so forth. So they give you a formula. Um, it's kind of wordy. Number of outcomes corresponding to A. In other words, all the number of the elements in that event that has that particular um, characteristic over all of the possible outcomes. The little n here is like the number of elements in the set. So n of u, let's say, is equal to the number of elements or outcomes in our case in the set. Whoop, that's it. Hmm. Oh, the marbles, the blue tickets, the red tickets. These are popular questions. But you just got to read them. Be careful because as we go, we'll spice it up. Like, do we take one? Do we put it back? And then we pull another one? Stuff like that. With or without replacement is when it gets a little bit more interesting. But here, we got 3 green, 4 yellow, 5 blue. Once again, it's good to know the total. So we have to do a little addition, 3, 4, 5. And maybe we want to know the probability of a green ticket. There are 3 that satisfy that particular characteristic over the total. Yes, I know, it's that easy. I'm pretty good here. A green or a yellow, so they both satisfy. So that means we do look at all the tickets that satisfy that condition, green or yellow. There's 7, great. Orange ticket, yep, not too many orange, so that's okay. You just say 0. There's 0 chance. Not gonna happen. That's fine. And a green, yellow, or a blue. Well, one of those is certainly gonna happen. So as desired, we get the 1 there. We get the 1. All right, we're gonna roll a lot of die in here, so it's important to see this. Let's just look at this whole example. Woo, I'm not too sure. Let's move that down a little bit. A little bit. It's my favorite dog name. A little bit. Heard somebody yelling for a little bit, and they had this collie, and the dog's name was a little bit. You're a little bit. That was awesome. All right, so an ordinary 6-sided die is rolled once. Beautiful. Determine the chance of getting a 6. Well, just like you thought, getting a 6, there's one of them over the total, 1/6. Hey, not getting a 6, interesting, is everything else, and there's 5, so 5 out of 6. C is 1 or a 2. So there are two possible solutions to that, and 2 over 6 is fine. Sure, if we want to get do well in the ACT, SAT, we'll probably reduce those fractions. 1/3 and not a 1 or 2, 2/3. Hey, what's important about this is both these scenarios, both the scenarios kind of are what we call complementary events, and they add up to 1. So 1/6 plus 5/6, complementary events, add up to 1. 1/3 and 2/3, they add up to 1. So really important that you do that. Now, to get this 5/6, we could have said 1 minus 1/6 and gotten that 5/6. You'll It was pretty darn easy to get the 5/6, but sometimes it's a little, if you have one probability, find the complement probability, I would just subtract it from 1. It's done. It's always right. There you go. So some of the material is given to you in a Venn diagram. Once again, if you can count, you can cook. That's what my mother-in-law always says. Wait, no, if you can read, you can cook. If you can count, you can do mathematics, I guess. All right, so in this Venn diagram, a little tired. The universal set, great, all the children in the class. Hey, you got blue eyes, or you don't have blue eyes, it looks like. So, and the dots are kind of painful because you're like, oh, I gotta count them. Yeah, so this is 8, not that big of a deal. And this is really close to 4 times 4. So let's see, 4. So 16, and then minus 1. So I got 15. And you would interpret that as 8 kids out of the class have blue eyes, 15 do not, with a total of 23 students. So blue eyes, 8 over 23. Not blue eyes, well, I could count and get 15 over 23, or I could have done 1 minus 8 23rds and gotten 15 23rds. Then I wouldn't have had to strain my eyeballs to count all those students. All right, we're going to get into gambling at some point. We're rolling the dice. This is a real famous little. It's not like a grid diagram because it's doing a little bit more than showing you the possibilities. It's saying what are the sums. So it's kind of cool. There is all the possible results. So there are 36 possibilities when you roll 2 die. But Mr. Sayers, a 2 and a 1 and a 1 and a 2, is that the same? No, not really. A 2 and a 1 can give you that, or a 2 and a 1 can give you that. There are 2 possible ways to get a 3. So you need to make sure you count those and not look at them as a 2 and a 1. Maybe have a blue die and a green die so you kind of see the difference. So what's the probability of rolling a 7? Well, you count up all the ones that satisfy that condition, and there are 1, 2, 3, 4, 5, 6 over 36. So when you roll 2 die, you have a 1/6 chance of getting a 7. What about an 11? 11 looks like there are 2, so 2 out of 36. A big thing in Vegas is a game called craps. Remember, when you are betting Vegas, they don't have those huge, big skyscrapers because they're like, wow, I can't believe we won today. It's because they're going to win. So if you go, just make sure when they take your money, you say, I love math. It works because it does. So lesson number 1. But there's a game called craps, and basically you bet that it's going to pass or not pass. And the first roll is pretty fun because if they roll a 7 or 11, you automatically win your money. Boom, and the game starts over in a new thing. We'll talk about that. But you pass if they get a 7 or 11. So you have an 8 out of 36 chance of winning, doubling your money just on the first roll. That's pretty cool. They don't really tell you though, a 2, 3, or 11, or 2, 3, 12, that's no good. So a 2, 3, or 12, there are 4 chances. So you have a 4 out of 36 chance to lose your money right away. You get anything else? It's a cool game. We'll talk about that later. All right, there's the assignment. Whoa, we're ready? Yeah, 10 minutes. Are you kidding me? The only thing I have left for you is a few hints on some of the homeworks. This is really good because it's kind of easy. It's nice. You just have to learn to make sure you're pulling the data. So please check your answers in the back and make sure you're doing this. Number five, the biggest thing I would think would something that would happen. You were definitely having three children in this family. It's in an order, no twins. Come on, so you can write. They give you GGB means a girl, then a boy. So I just wanted to be very clear that if you have BBG and BGB, those are two different outcomes. So kind of look at that as one and that as one. They both have two boys and a girl, but they're considered different outcomes. Number nine, back to the rolling two die. I just want to kind of illustrate maybe one of those. So if we find the probability of a five or a six, a lot of times when we say the word or, some people think, okay, you can't have a five and a six. No, no. So yes, you can. Usually in the word or, it's it's inclusive, meaning it allows both. So be careful, check things out. So what I did is I marked in green all the outcomes that have a five in it, and I marked in purple all the outcomes that have a six. Notice we're going to have 2 points of where we have a five and a six, but those count. So this is the only thing I like about the grid is that you can just count them. All the dots there that have uh, green, purple, or both count. So if you count them up, there are 20. So the answer for C is 20 over 36. 20 over 36. You could think about it as there are 11 rolls out there with a 5. There are 11 rolls out there with a 6, and there are 2 rolls that have been counted twice. That's where those overlaps are. I think it's easier with the grid, but get used to that. You're going to want to revisit that. Hey, last one, a little help. This is a Venn diagram with 3 bubbles. There are 3 events. One is all these people that like Chinese food. One of these, all these people like Italian, or Thai food. Oh, I love Thai food and Indian, Italian, and I love Chinese food. So, all right, let's look at number B2. B2. So, can you count the number of people that like Italian and Thai? So, notice I've marked the 7 and the 4 there. They are in both circles for Italian and Thai. Yeah, the 7 includes Chinese, but in that one it doesn't say that they can like something else or they don't have to, or they only can like Italian and Thai. So that's the important thing. And if you look at the green, Chinese and Italian, but not Thai. So that's where the 8 comes in. See how it satisfies the Chinese, the Italian, but it's outside the circle of Thai. Outside the circle of Thai. There's something cool with that. All right, there's the problems again. So toodaloo.